y of x equals 2 over x. And let's say for problem B, 4t squared, forgot my f of t. Say f of t equals 4t squared over 5. Okay. Alright, so for A, if you have y of x equals 2 over x, you can just bring that constant right out to the front. 2 times 1 over x. Or you can just make it y of x equals 2 times x to the negative 1. Okay, so to find the derivative of that, y prime of x is equal to, you can just leave the 2 alone and multiply that by the derivative of x to the minus 1 power. So you bring down your negative 1, x, negative 1 minus 1. Okay, so your y prime of x, you have that 2 times negative 1, which is negative 2. X to the negative 1 times, minus 1 is x to the negative 2. So that, or y prime of x is equal to negative 2 over x squared. Okay. So all you do is you just pull the constant out the way, do your derivative, and then multiply it by whatever the derivative is. All right. Any questions on that one? All right. Okay, so let's say for problem B, f of t equals 4t squared over 5. You can actually just bring that fraction right out to the front. So f prime of t is going to equal 4/5. Well, let me rewrite it first. F of t equals 4/5 times t squared. There we go. Okay. So f prime of t, just going to bring the 4/5 right out to the front and just find the derivative of the t squared. So you're going to bring that 2 right out to the front, t to the 2 minus 1. Okay, so your f prime of t is going to equal 4/5 times 2 is 8 over 5. T to the 2 minus 1 is just t. Or you can just put the t in the numerator if you wanted to. Either way, it still works. All right. Any questions on that one? All right. I'll leave that up for a few seconds.
You times 4/5 by 2, and that's how you got the 8/5.
Yeah. Or you could have just wrote it as 4/5 times 2 over 1, t to the 2 minus 1. Then it's just 8 over 5. Oh, there we go. All right. Okay, so let's say if we have, what is the derivative of f of x equals negative 2/5 x to the power of 3/4. at the point x equals 1. Okay, so with this one, all you have to do is first find the derivative, and once you find the derivative, plug in 1. I'll let you get started on this one. You really shouldn't need a calculator for this one, because 1 to the power of anything is just going to be 1. That's why I picked 1. It's nice and easy. All right, so let's get this one. Okay, so we know our f of x, -2/5, x to the 3/4. So your f prime of x, you get your -2/5 and just bring it right out to the front. You bring down your 3/4, you subtract 1. Okay, so this one, we can just do that right on the side over here. So 3/4 minus 1, you can rewrite that as 3/4 minus 4/4, which is -1/4. Okay, so your f prime of x is going to equal negative 2 times 3, which is negative 6, 5 times 4, which is 20, x to the negative 1/4, which that actually reduces to negative 3/10, x to the negative 1/4. Okay. Now when x is equal to 1, you just plug in 1 there. That means your f prime of 1 is just negative 3/10 times 1 to the negative 1/4. Okay, so f prime of 1, 1 to the power of anything is always going to be 1. It's negative 3/10. Okay. So this means for the graph, if you were to graph this one, f of x equals negative 2/5 x to the 3/4, the slope of the tangent line is negative 3/10. Oh.
I wrote it down wrong. Just trying to figure out how you got negative 620 as the, and I see 2/5. I wrote down 2/3.
Oh, okay. Oh, that is negative 3/10. Okay. So you may see the max for the derivative, you may see the max for the slope of the tangent line. The exact same thing. They have a million different ways of asking for the same thing. All right, any questions on this one? All right, I'll leave this up for a few more seconds. All right. Okay. So you have the sum and difference rules. Which they kind of remind you of the distributive property, which just states that the derivative with respect to x of f of x plus g of x. So if you have two functions and you want to find the derivative and they're added together, kind of distribute it to both. So it's going to be the derivative of the f of x plus the derivative, let me write it out the other way, respect of f of x plus the derivative with respect to x of g of x, which is just f prime of x plus g prime of x. Okay. Same thing with subtraction. Okay. So if you have the derivative with respect to x of f of x minus g of x, again, you just kind of distribute it to both of them. So the derivative with respect to x of f of x minus the derivative with respect to x of g of x, which again is just f of x minus f prime of x minus g prime of x. Okay. So as obvious as this might seem, we do have a proof. Actually had somebody write that on a test once. It's obvious. Yeah. Still got to prove it. All right, so the proof of that, what if we let our f of x, well, let's say we want to find the derivative of f of x plus g of x. Okay, so we know that's going to equal, I'll put this over here, the limit as h approaches 0 of f of x plus h plus g of x plus h. Remember, that's our kind of f plus h. Minus f of x plus g of x all over h. As h approaches 0, I already put that. Okay, so the limit as h approaches 0 of f of x plus h plus g of x plus h, if we distribute that negative, minus f of x minus g of x all over h, then we can kind of maneuver them around a little bit. So the limit as h approaches 0, f of x plus h, move that minus f of x over here, plus g of x plus h minus g of x all over h. Okay. Which means if we wanted to, we can separate this into two separate fractions. So we have the limit as h approaches 0, f of x plus h minus f of x all over h, plus g of x, plus h, minus g of x all over h. Okay, so just like before from the limit properties, we just apply the limit to both of those. The limit as h approaches 0 of f of x plus h minus f of x all over h, plus the limit g of x plus h minus g of x all over h as h approaches 0. This is our f prime of x plus our g prime of x. We'll bring that up a little bit. I was actually going to tell you to not bypass the proofs because one or two of them may appear on the test. Don't sound so happy. I'm like, okay.
That's the long way. You teach us a shortcut and then still got to do the long way.
Well, it's more about concept than
Yeah, I understand.
speed.
I understand why. I gotcha.
Yep, limits kind of hang around for a while.
Okay.
Yes.
Didn't you say you were able to separate it from the last step instead of just saying f of, because what I was able to deduct from that was f of h plus g of h over h. I think I just did that wrong because I was thinking you could just add it, or I don't know, distribute the f of x plus h, the g of x plus h, and then you get some, you would just get f of x plus minus f of x plus f of h plus g of x plus g of h minus g of x minus 2.
You lost me like halfway in there.
He's treating the f and the g like a constant. You can't distribute them.
Okay, I see what you're saying. Okay.
Gotcha.
Okay.
So, wait, so we are past derivatives, or?
F and the g can't be treated as a constant.
Okay, you were distributing that?
Yeah.
Oh, okay, I see what you're saying. Okay, yeah.
So if then you treat them like a constant, then.
Well, it's not really a constant if you think about.
It's just telling you that's
Yeah.
one function of x and that's
Oh,
another
yeah.
function of x.
Oh,
So remember, let's say if this was your f of x plus h, let's say that was a different one.
So we're taking the entire derivative of that, which means
Yeah.
that, oh,
Yep, the whole x plus h of that
Oh.
whole thing. And then the x of that whole thing, all over h.
Okay, so that's why we can't subtract it, because it's two different entire things. Gotcha.
Exactly. Yeah.
Okay. And then that's how we can move it around then at that point. Then.
Yeah. Mhm. Any other questions on this one? All right.
You said some of the proofs will be on the test?
Yes. So I'm giving you like weeks and weeks and weeks of notice. So.
Mine is right before the test.
Oh, if it's just before the test,
Oh, it's just.
it's a lot of trouble. All right, so let's say if you have, for example, we'll actually do two examples in one. They'll sometimes word it, go clean that up a little bit. Just 21 minutes. Should beat it before it shuts off at 30. Let's say for which values does f of x, should be able to squeeze that, equals x to the third over 3 minus 2x squared minus 2x plus 6 have a tangent slope of negative 6. Okay. So tangent slope of negative 6 is just a fancy way to say where f prime of x equals 6. Oh, negative 6. Okay. So all you have to do is find the derivative and then find where the derivative is negative 6. And that will tell you that if you graph this one and you say, okay, at this point and this point, they'll both have a slope of negative 6 at those 2 points. So f prime of x is going to equal, instead of x to the third over 3, I'm going to make that 1/3 times x to the third. And let's say the derivative of x to the third minus 2 times the derivative of just x squared minus 2, remember that's the derivative of x, plus the derivative of 6. All right, so that's going to be 1/3. Oh, clean that up some. Derivative of x to the third, you're going to bring the 3 down to the front and subtract 1. Minus 2, derivative of x squared, you're going to bring that 2 down to the front and subtract 1. Minus 2, that's just a 1. If you wanted to put that there, you can. But we already know the derivative of x is just going to be 1. Plus the derivative of a constant, that's just 0. So we know that automatically. Okay, so these two 3's cancel each other out. So you have x to the second power minus 2 times 2 is 4. X to the 2 minus 1 is just x to the first power minus 2 times 1 is just 2. X to the 1 minus 1, x to the 0 is just 1, so you can leave that there. And that's 0, so we know our f prime of x is equal to that. Okay. So now we just have to find out where our f prime of x is equal to negative 6. Hmm?
Right, the last one, the sixth, the derivative
Yep, derivative of a constant is always 0.
is always there.
Yep.
So at this point, we just plug in -6?
Nope, you don't plug in -6. We have to find out where it's equal to 6.
Okay.
Yep, so if you had,
So you would put all that equal to 6?
yep, so if you had a graph, let's say it looks like that, then you can say, okay, at this point, the slope is -6, and at, let's say at this point, the slope is -6. So we'll be able to find where the slope is -6 just from doing this. So f of prime of x equals -6,
Which equals x squared.
that means that x squared minus 4x minus 2 equals -6. Okay. If we were to plug in the -6, it would have just showed us what the slope was at -6. It wouldn't have showed us where the slope is -6 on the graph.
Where the slope was, you said?
Hmm?
Where the slope was at -6 is if you plug it in?
Oh yeah, if you just plugged it in, it just tell you the slope at -6.
But we're trying to find the tangent slope, which is...
Yep, we're trying to find on that entire graph which points have slopes of -6.
Oh, okay.
Yep. Okay, so that gives us x squared minus 4x. And if we add 6 to both sides, plus 4 equals 0. Okay, which is here just basic factoring. Find two numbers that multiply to equal your c. Those same two numbers add to equal your b. Okay. Oh, -4. So that's just -2 and -2. Okay, so -2 times -2 is +4, and -2 plus -2 is -4. So you end up with x minus 2 times x minus 2 equals 0, which is just x equals 2. Oh, sorry about that.
Question, so
Mhm.
if, let's say those, it's x, let's say you got x plus 2 and x minus 2,
Mhm.
is it possible to have 2?
Oh yeah, you can have multiple. If you have a graph that goes in different shapes, you may have one point where the slope is -6, and then another point where it's -6, and then a different point where it's -6. The same way you can have a slope where, let's say if you have this slope like this and goes down again. Let's clean that up a little bit.
So let's say they didn't have that -4, 6, it was just x squared plus 4,
Mhm.
or minus 4, and then you have x plus 2 and x minus 2.
Yep, and that means that,
That means they would have a slope at 2 different locations.
yep, at two different locations, that's the same direction.
Right.
All right, so here, let's say if you have this point here, this point here, and this point here, remember this is where your slope is equal to 0. Okay, which means here you have a positive slope and negative slopes. Here you have a positive slope and negative slope. But those are where you have your horizontal slopes. That's when it's equal to 0. So sometimes, actually the next example, I believe, nope. I think the example after that deals in that. So you're always going to have like your positives, your negatives, and all of that. Yes?
Did you do quadratic formula here?
Nope, I did just the basic factoring.
Could you do it?
Oh, could you? Oh, yeah.
Okay.
Yep.
That's like the
So
square root BA 4C something?
Yep. Negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah.
Oh. Let me re-
Good thing.
So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, yep, you could have used that one if you wanted to.
It's obviously a lot more complicated though, but if there was a problem on the Newton Alta that...
Oh yeah, you could do,
factor it out.
yeah, you can do regular factoring, you can do the AC method, you can do factoring by grouping, you can do that one, depends on the problem.
Yeah.
So you would use that if it was like complicated. We
Mm.
can't just look at it and factor it.
Yeah,